In this video, we're going to look at how to solve for sides in a right triangle using SOHCAHTOA. Okay, so your first step is always to label your triangle with the opposite, adjacent, hypotenuse based on your reference angle. And your reference angle is going to be the angle, not the 90-degree one, the other angle that is given to you. So in this case, it's going to be the 35 degrees. So with reference to the 35 degrees, x is going to be my opposite side. This AC is going to be my adjacent, and the hypotenuse is always across from that right angle. Okay, so now we want to see, okay, what side am I given and what am I looking for? So I am looking for my opposite side and I'm given my hypotenuse. So now I try to think, okay, using SOHCAHTOA, what ratio would satisfy opposite and hypotenuse? And that would be sine. So this problem deals with op and hyp, so that is our sine function. So now we're going to write down that original general formula. Sine theta equals opposite over hypotenuse. Okay, and remember, your sine, cos, tan, they're always attached to an angle. You can't just write sine equals opposite over hypotenuse. There has to be an angle attached. So now we're going to replace everything that we're given. So sine, my reference angle is 35 degrees, is equal to my opposite side, which is x, over my hypotenuse, which is 15. Now we can put this sine 35 over 1 and we're going to cross multiply. And when I cross multiply, I cross the x with the 1 and the 15 with the sine 35. So we're going to have x equals 15 times sine 35. Please put that coefficient in front of sine so that when you plug it into your calculator doesn't accidentally multiply the 35 degree with the 15 and take the sine of that. Okay, and the reason I also don't put sine 35 in my calculator right away is because I want to keep the accuracy. So now I go to my calculator and in one step I'm going to type in 15 sine 35 and I get approximately 8.6. And I'm going to round to one decimal place, and I use my squiggly equal signs because I'm rounding my answer. Okay, so that's really all you're doing for solving for a side. Label your triangle, figure out what you should use, sine, cos, or tan, based on the side you're looking and the side that's given, and then cross multiply. Let's try one more. Okay, so again, I'm going to find my reference angle, and in this case it's the 41, and I'm going to label. Across from the 41 is opposite, across from the right angle is the hypotenuse, and the leftover is my adjacent side. Okay, so I am looking for the hypotenuse, I am given the adjacent, so in this case we're going to be using cosine, ka. So adjacent and hypotenuse. So again, I'm going to write my general formula. Cos theta equals adjacent over hypotenuse, and I'm just going to substitute what is given to me. So the reference is 41, my adjacent is 20, and my hypotenuse is x. And I'm going to put that cos 41 over 1 so that I can cross multiply. Now in this case, it's not going to be one quick calculation. We're multiplying x by cos 41, and we're multiplying the 1 by the 20. So now I need to isolate for x. What's getting in my way? That cos 41. And the cos 41 is attached by multiplication, so I'm going to divide it out. Which means my x is actually going to equal 20 divided by cos 41. And that's what I'm going to plug into my calculator. Okay, and I do this in one step. So 20 divided by cos 41, and I get approximately 26.5. And do a logic check for yourself. In this case, we were solving for the hypotenuse, and the hypotenuse is supposed to be the longest side. Is 26.5 greater than that 20 that was given to us? Yes, so this is a possible answer that actually makes sense. Now, there was a little hint in example 1 that I want to look at. Okay, it tells us that we're going to cross multiply and solve for x. Now, here's a little trick. If the x is on top, you will multiply to arrive to your answer. Okay, so in this case right here, when I cross multiplied, I had x on top and I just had to multiply the 15 by the sine 35. It was one clean step. Okay, however, if x is on the bottom, you're going to divide to arrive at your answer. So if we look over here, x was on the bottom, and what I ended up doing, I didn't multiply the 20 by the cos 41. I kind of switched the places of x and cos 41 so that it turned into division. So that's just a little shortcut you can use if you want to. If x is on top, multiply. If x is on the bottom, divide. Otherwise, cross multiplication is obviously perfectly fine, and that's what I do anyway. Okay, so now we're going to try two application problems. So we're going to be given a scenario. We have to create our right triangle so that we can solve for a missing side later on. So in this question, it says, from a point on the ground 25 feet from the foot of a tree, the angle of elevation of the top of the tree is 32 degrees. Find to the nearest foot the height of the tree. So I know I'm going to be looking for this. That's my x. It says there's a point on the ground, so I'm going to draw a straight line. And this point here is 25 feet from the base of the tree. Now it talks about an angle of elevation. An angle of elevation is if you're standing on the ground, and it's the angle formed between the horizontal line and your sight line looking up to the top of a building, a tree, or whatever object it is. So in this case, if you're on the ground and you're looking up to the top of the tree, your angle of elevation is right here, between the horizontal line and you looking up. Okay, now I know I'm looking for the height of the tree. I have an angle, I have another side. Now I can label my triangle to do SOHCAHTOA. So here's my reference, the 32. Across from the 32 degrees is my opposite. Across from the right angle is the hypotenuse. And again, we're going to be assuming that our tree is standing upright and it's not lopsided. And then our leftover is the adjacent. So I am looking for my opposite side. I'm given adjacent. That is us dealing with the TOA, so that is tan. So I'm going to start off by writing my original formula. Tan theta equals opposite over adjacent. And I'm going to plug in what I have. So my reference angle is 32 degrees. My opposite is x, and my adjacent is 25. And we can put that over 1 if we want to cross multiply. Or if you notice that x is on top, which means we have to multiply, then we're going to be doing 25 times tan 32, which is what you get when you cross multiply as well. X times 1 equals 25 times tan 32. And now we're going to round our answer to the nearest foot. So in my calculator, I'm going to do 25 times tan 32, and I get approximately, it says 15.6, so I'm going to round that up to 16 feet. And because this is a word problem, I'm going to write my therefore statement. Therefore, the tree is 16 feet tall. Okay, so take the key information, create a right triangle, label it based on the information given, and then solve for the sides like we did in the previous two examples. Let's try one more. Okay, from the top of a barn, 25 feet tall, you see a cat on the ground. The angle of depression of the cat is 40 degrees. How many feet to the nearest foot must the cat walk to reach the barn? Okay, first thing they tell us, the barn is 20 feet tall. So that's the height. There's a cat on the ground, so I'm going to draw a horizontal line to my cat. And then it says that there is an angle of depression. Now the angle of depression is a little different from the angle of elevation. The angle of elevation, you're on the ground. The angle of depression, you're up on top of a building or a barn, hot air balloon, whatever it may be, and you're looking down at an object. Now the angle of depression is going to be the angle of the horizontal line, so that's going to be in the sky, down to what you're looking at. So I'm going to create a triangle right here. And now my angle of depression, I draw a horizontal line. My angle of depression is this one right here, 40 degrees. It's not inside the triangle. It is not this angle here, it's here. The horizontal line and the object you're looking at. That's your angle of depression. Now, to get that angle inside of our triangle, we can do a quick Z pattern right here, which means this angle where the cat is also 40 degrees. And now we have to figure out what are we looking for. It says how many feet must the cat walk to reach the barn? So this is our X, the ground. And now we can label. from the 40 degrees as our reference, our opposite is the 25 feet barn, the hypotenuse is across from that right angle, and the base is our adjacent. I'm looking for adjacent, I have opposite, we're going to be using tan again. So tan theta equals opposite over adjacent, and I put my reference angle in, which is 40. My opposite is 25, and my adjacent is x. Now here you can do a shortcut. Okay, I see my x's on the bottom, so I can do a quick little swap right here. I put the x where the tan 40 is, and take the tan 40 and put it where the x is. Okay, and that would be the shortcut. X equals 25 over tan 40. If that's something you're going to forget, definitely do your cross multiplying. Okay, so if you cross multiply, okay, I'm just going to do a side step here. You would have x tan 40 equals 25, and then you would divide out the tan 40. And then you're going to get back to what we have on our left side. And at this point, we can go to our calculator. It says to round to the nearest foot. So 25 divided by tan 40. And I have 29.79. To the nearest foot, that would be 30 feet. Therefore, the cat must walk 30 feet. And that's it. So I want you to read over this handout, but I do want to go over again this angle of elevation and depression that I mentioned in the previous example. So your angle of elevation is always measured from the horizontal line of sight up. So this is what you would be looking, that's the direction you'd be looking in if you were on the ground and you're looking up to an object. So the angle that is formed right here, that is your angle of elevation. If an angle of depression is measured from the horizontal line of sight down. So if you're up on a lighthouse or whatever it may be, your horizontal line is up here, that's your horizon, and you're looking down at the object. So that's the angle that's being formed. So the angle of depression is outside the triangle, while the angle of elevation is inside the triangle. But again, for an angle of depression, we can use our Z pattern to get an angle inside. Or we know complementary angles form a 90-degree angle. So right over here, this 35 degrees with this angle here, they add up to 90. So you can figure out this angle. But most people like to use the Z pattern because it's a lot quicker, it doesn't involve the calculator.